Okay, so we are just going to be kind of wrapping up the tiniest unit of the year today. And just to make sure everybody knows, we are going to be doing a review on Tuesday, and your test is going to be on Thursday. Okay, everybody clear on that? Test Thursday, review Tuesday. When are your test corrections due? Tuesday. Now, I have a whole bunch of folks that were absent for the quiz. I'm going to try to get you guys to at least be able to start working on your corrections during Flex today. Bless you. But I can't actually send the corrections outside of the classroom until I get a lot. I've got like 10 people that have to take it. So I can't give them out quite yet. Okay? All right, so let's start looking at this lovely little warm-up. Take a look at the answers. And again, this is just the answers. I will work them out separately if you'd like to see them. Just wanted to make sure it was clear. And I did the answer in 2 ways. You could choose. It's a lot prettier on my paper. My paper looks pretty. Because you know, when it comes to math, it's all about looks. I will answer questions, just giving you a chance to check your answers, at least for the first 4. Still kind of struggling on this a little bit, what I've noticed. You got to keep your rules straight. Yes, sir. For number 2, so you got those numbers. You got the -1 and the 4/5. Okay, so if you have those numbers correct, what we've got here, that tells me that you would have factored that correctly and had the same factors that I have. Yeah? Okay. So we have -1 and 4/5. You know that they're going to be open circles because natural log or logs have to be greater than 0. You cannot be equal to. And then it becomes a matter of checking values. So if I plug 0 in here, that would be 1 and -4. That does not work. Okay, because that'll give me a negative number. If I plug in a -2, that'll be negative. That'll be negative, which makes it positive, which works. If I plug in a +1, that would work, and that would work, because that'd be positive and a positive. So that's how I get that x is less than -1. And you've got to be really careful, ladies and gentlemen. A lot of folks see 2 numbers, and they automatically just want to say, well, I know the sign for log is greater than or equal, or just greater than 0. So they want to put a greater than symbol on those automatically. Don't do that. Whenever you have multiple, like literally multiplication, or you have division, check. Because it's not going to be as obvious as it may at first seem. Okay. Any of those other ones? 1, 2, 3, 4. I declare a thumb war. Yes. Okay, so for number 4, there's only one thing. There's no number I can put in the top to get 0, right? But there is a number in the denominator. If I put a 4 in there, I get a 0 out, and I know that's bad. So again, with that one, looking at the idea that I know I have 4, I know it can't beat 4, so now it's just a matter of checking. If I put 0, that's going to be a negative. Not going to work. 5, that's going to be positive, so that does work. Okay? Take the second to do it visually to make sure that you're on the right track. There's nothing wrong with that. For number 3, okay? So for number 3, we start off with that square root of 3x cubed minus x to the 4th. So the rule for that one, what's the general rule? What are my restrictions here? Yeah, all of that stuff has to be greater than or equal to 0. So that stuff here must be greater than or equal to 0. Which means if I have multiple variables, I am going to have to factor, or if I have higher powers. What can I factor out of this? X cubed. And when I take the x cubed out, I'm left with 3 minus x. From here, we get 0. From here, we get 3. Are you okay up to that part? Now, when you have higher powers on x, it gets really kind of weird to know where your values go. So I have 0 and I have 3. This said greater than or equal to, so I will close in those circles. And I'm just going to check, just like usual. I'm going to check to see, plugging things in, will I get a positive value? So when I plug in a negative number, negative cubed is negative. 3 minus a negative would become a positive. Negative times a positive, nope, that doesn't work. If I plug in a positive 1, that would be 1. That would be 2. Positive, positive. That works. If I try 4, that would be positive. That would be negative. So that doesn't work. So my answer is only between those two pieces. Okay, and we're using, if you're using the interval notation, please make sure you use brackets on those rather than parentheses. Because it starts off as a square root. Square roots, you can be equal to 0. You can take a square root of 0, but it has to be positive. Okay? Logs cannot be 0. Logs and denominators are the ones that cannot be 0. Yes, ma'am? So number 1, we have a fraction, and I know for fractions what has to be true. Not equal to 0. I have an odd root. Do I have restrictions from odd roots? If you're not sure, think about it. Can I take the cube root of negative 1? Yeah. Can I take the cube root of 0? Can I take the cube root of 1? So I have no restrictions from cube roots. So the only thing that I have is that denominator cannot be equal to 0. And therefore it's the 2 that causes the problem. All right. Let's take a look at the final ones. Yes, sir? If I put negative 1 in here, that's going to be a positive 1. That's going to be a minus 1. 1 minus 1 is, can I divide by 0? It's understanding that you have to combine those two rules for this. So for the root, I have greater than or equal to 0. For the fraction, I have cannot equal 0. So we've got to go the strictest way possible, which means I just have to be greater than 0 here. Yes? What? Yes. The only time you don't have to include the all real numbers is if you're already giving me a range. If you just say x can't be negative 5, it's not answering, well, what can it be? So this is answering the question, what can it be? And it's just easier to say anything but 5 or negative 5. Okay? Yes. So for number 6, are you okay with the fact that I don't care about the 2? Okay? So that means I'm looking at that square root of x squared plus x cubed, and that's in the denominator of stuff. So if it's in the denominator, I know immediately that that whole thing cannot be equal to 0. I also know that this guy, because it's under a square root, has to be greater than or equal to 0, but not equal to 0. So that means I'm going to solve x squared plus x cubed greater than 0. So far, so good. How do I solve that? Factor out what? And when I factor out x squared, I will have, so from here, what number do you get? From here, what number do you get? That means when I'm looking at this, -1 is on this side, positive, well, 0 doesn't have a sign, is over here. Well, I have open or closed circles. Open. And then you're just going to check the pieces. It does not work here. It does work here, and it does work here. Now, you've got to be careful, because it looks like if I were to talk about where my answer is, it looks like I'm just saying things bigger than -1. But it doesn't include 0. Yes, sir. Which problem are we talking about? Which problem are we talking about? Okay. Right, right. Like this one can't equal 5. You just have to tell me what it can be. This is what you're telling me what it can be. So you're already giving me something to look at. Okay? So if I have just a can't be, I need the all real numbers. Anything else, I don't need the all real numbers. Okay? All right. What about your homework? Never trust 4 homework questions. Sophia. 41. Start with 41, what it said first. 41 said f of x is x squared plus 1. G of x is root x minus 1, and you wanted b as in boy. Okay, so that's g of f. So first off, for g of f, that means g, and in goes f. Are there any restrictions for f? No, so I'm not going to worry about that. So now I'm just going to continue on with my problem. That means I'm going to take g, and in it is going to... No. 1 minus 1, which cancel each other out, x squared. Now, if you were looking at the answer in the back of the book, the way it was written was probably kind of confusing. But you have to understand, if I square something, that number is always going to be positive, right? And it says square root, so it's not saying x squared equals a number, it just says square root. That's why in the back of the book, you need that value of x, because your answer is always going to be positive. Because even if x was -1, -1 squared is positive 1. Square root of positive 1 is positive 1. I'm not going to get on to you about that, but just know that it's actually only going to be the positives. Okay? Yes? For this one? Okay? So g of g is g of g of f. Let's start off with g. Do I have restrictions on g? What? Greater than or equal to 1. All right, so I know that. I can't forget that. Let's just start doing the math, though. So that means I'm going to have square root of stuff, where that stuff is x minus 1. That's ugly. Fell off the ugly tree and hit every branch on the way down. That's what we're going to do in here. It gets a little weird, though, because you're seeing here we've got a... is confusing. Do that. You would say x minus 1 has to be greater than or equal to 0. And then you would say the square root of x minus 1 has to be greater than or equal to 1. So far, so good. And square both sides, and we're going to have to just think about how the values work out. We would have x minus 1 and 1 then I would have x and 2. So I'd have to kind of think. So I have a 2. I know I have to be bigger than 1. If I were to pick like 1/2, right? Because that's 1 1/2, because that's bigger than that but less. 1 1/2, I would have a positive number here, but it would be small. So that whole thing would be negative, so that doesn't work. If I pulled up at a 2, it would work, and it would work for everything out. I'm not going to do that to you on a test or quiz. Okay? But this is all we can do writing that. Yes, sir. $40 gives me f of x is the square root of x minus 2. G of x is 1 minus 2x. And you wanted which one? B? Well, that would help if you could see it. Thank you. B is g of f. So who do I get my restrictions from? F. So from f, we start off with the fact that x has to be greater than or equal to 2. And then g of f means I'm going to start with g. In goes f. That means I just have 1 minus 2 root x minus 2. There's nothing more you can do with that. And when I don't have a restriction from this outside, the restriction that I have still comes from just that same spot. So we're still sticking with the idea that x has to be greater than or equal to 2. Well, I would have written like that. Okay. Last question. Michaela. Okay. Sure. And D was G of G. So I'll just write down G then. So we have that. And G of G. First off, looking at that, restrictions. X can't be 0. So far, so good. Then I have G over G. This is a little icky. You can do this several different ways. You can say the common denominator here is x and times both pieces by x. And in doing so, you would have 2x over 2, which is x. Or you could do 2 times the reciprocal, which again gives you x. But then you just have to have that restriction. It can be anything but 0. Okay. All right, go ahead and clear your... No quizzes. What am I talking about? It's like, wait a minute. I don't think I recall saying you'd have a quiz. Okay. You don't. No quiz. You're okay. You will have a test over it. Just not today. All right. Last itty-bitty thing. And again, it's something that you've talked about before. It's just been a while. What we are dealing with is going to be, again, composition of functions. But we're also talking about inverse of functions. So here are two functions, f and g. I want you all to find f of g, and I want you to find g of f. Go ahead and be amazing. F of g and g of f. So hopefully that one was pretty quick. You got those done? What did you get for f of g? What about g of f? That is a special thing. And I also just wanted to comment on the fact that the final domains on this, these are obviously an easy problem. The domain for both of these is all real numbers. The domain for both of these is all real numbers. But you'll also see that work out. When you have two functions, and you can do f of g and g of f, and get x as your final answer, they're inverses of each other. That's what an inverse is. How can I find an inverse? Do you guys remember how to find an inverse? Like if I wanted to go from this to this, how could I have done that? If I had started with the y equals 2x minus 6, and I wanted to find an inverse, anybody know what to do? You don't set them equal to each other, but you switch the x and y. So it would be saying x is equal to 2y minus 6. What would you do? Add 6 and divide by 2. And we would mark that y to the negative 1. I know it looks a lot like negative 1 power, but it's a little different here, is equal to 1/2 x plus 3. That is what it means to be inverse. So you can think about it a couple of different ways. If f is xy, then the inverse of f, which we call f to the negative 1, is just yx. And so we get to say that two functions are going to be inverses of each other if, when I do a composition both directions, f of g and g of f, you get just x at the end. So if f is xy, the inverse of f is yx. So that can make for a very simple problem. I'll give you a chance to go ahead and write these guys down, because I know I move a little quickly sometimes. So if this here is f of x, what would I do for the inverse? Boom! That's it. Those of you who didn't hear, switch the x and y. Nope. I don't know how to switch things. Okay, so that actually should be, this is why I liked my erasable pens. It just stopped working on me. That'd be 4, 6. Is this guy here a function? Just curious. The initial guy, this guy a function? Not always going to be the case. Okay? But both of those are functions. And basically, if you can do an inverse, this is something that's called 1 to 1. And that means 1x, 1y. Each x has only one y. Each y only has one x. That's how you know something has an inverse. You can do that. So if this is my function, what would the inverse be? For this next one. 2, 4. -2, -3. And 5, 5. An inverse idea is pretty straightforward. You are flipping the x and the y. Okay? How are we doing with that? I think in kind of like just looking at it from afar, all of what we're doing this unit is pretty straightforward. Hey, add them, subtract them, multiply them, divide them, composition, substitution, switch x and y. Simple ideas. The problem comes when you do the math behind it. That's where it gets hard. So let's actually do some stuff that has more math in it rather than let's just flip-flop them around. Yay! So contain your excitement. We're going to start. Okay. kind of stepping from one stone to the next. So last class we were talking about compositions. Right now we're going to use compositions to determine if they are in fact inverses. So go ahead and write down problem number 1. With this stuff here, I cannot be clear enough. I can tell you right now, the issues you are going to have is to try to move too fast through the problem. I am going to be picky about the work that you show, because the order that you do this in either makes it okay or not okay. Problem number 1, we're just using compositions. So that means I'm going to start with whatever one you want. I'm just going to do f of g because I want to. That means I am going to start with f, and in goes g. Do I need those parentheses? What would that be? -8. Ladies and gentlemen, we don't have to go ridiculously far on that. My question is, would I be able to get to equals x in the end? Will that ever simplify all the way down to just an x? No. That does not happen. Not an inverse. Just so you know, if you come to a point where it says that, nope, not going to work, don't like it, the other one's not going to work either. I mean, if you really want to, you can go through and say, all right, then g of f would give me this, where the root x minus 4 goes in, but square and square root cancel each other out. Is that going to be equal to x? No, again. If you are showing whether or not something is an inverse, and you find that the first way doesn't work, this second part is not needed. You don't need to do the other way. Okay? Since the first one came out as not an inverse, you don't need to do the second one. But sometimes that means it's nice if you can just try what you think is going to be easier first. So go ahead and write down problem number 2, and this goes back to one of the questions was about how do you deal with composition with fractions. So go ahead and write down problem number 2. I want to know with number 2, do you have a preference? Do you want to do f of g or g of f first? You're just going to do f of g? Okay. Really doesn't matter. I'm just letting y'all give me some input here. So I'm going to do f of g, boop, 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 fog. And that means I'm going to start with f, and in is going to go g. What to do, what to do, what to do. There you go. So we're going to take all of the top, the numerator, and all of the bottom, the denominator, and I'm going to times the whole thing by x minus 1 over x minus 1. Because basically I'm just multiplying here by 1. So I'm not changing the value, but I'm changing the way it looks. This is going to clear our fraction. That means when I distribute here, x minus 1 times this piece, what is that going to give me? 2x plus 4, very good. Plus 4x minus 4, beautiful. And what is it going to be in the denominator? Thank you very much. Dana? Ooh, so close. You're going to have the 2x plus 4. You're going to have minus 2x plus 2. Number one mistake on the quiz. That exact thing right there, a negative times a negative. Make sure you distribute that. All right, so let's see what I get. The thing that you want to be careful with is you can only do one operation to a number at a time. For example, I can see here that the 4 and the 4 will cancel each other out. I can see here that the 2x and the minus 2x will cancel each other out. At this stage, but I'm not going to be then dealing with the rest of it. So now I've got, what is 2x plus 4x? 4 plus 2? And that equals x, right? You okay with that? So that direction tells me I should be okay with inverses. But, and this is not my rule, this is math's rule, you must verify it both ways. Because there are problems get wrong. So even though the x, and that tells me that's good, I still need to do g of f. I wish I could tell you something different, but yeah, they're a pain in the neck. Why don't you all see if you can do g of f? Work fraction all the way. But let's take a look at the answer here. Do not try to do more than one thing with your numbers at a time. Yes, ma'am. Mm-hmm. That's fine. Something like that where it's just distribution, that's okay. You started here. That's okay. That's okay. I'm more concerned about when you start canceling things out. All right. This one is a good example. So go ahead and copy down for me, please, problem number 3. And by the way, when we had this, these are inverses. Yes, ma'am. Yep, you just write they are inverses. Thank you. Sorry about that. For number 2, they were inverses. So you just literally write down they are inverses. Because the question was a yes or no question. Determine if they are. They are. Do you have a preference for number 3? Do you want to do f of g or g of f first? I don't care. You would... Okay, well... Oh, okay. Just to show you that it doesn't matter. We'll do g of f. That means I am going to take 2 to a power minus 3. Be very careful how you write these because you've got exponents, you've got bases, you've got all sorts of stuff. And what's going in there now is log base 2 of x plus 3. This guy is where I'm talking about that you cannot just cancel things willy-nilly. You need to show me what you're doing. So what can you do? Right, 2 and the log base 2, so that leaves me with x plus 3 minus 3. So what is that? X. It looked scary to start with. but that was a heck of a lot nicer than the fractions. So that's what I wanted to see. Now let's see if that was just a fluke. Was it just one direction, or are they both okay? So f of g means start with log base 2, and into that is going to go the 2 to the x minus 3. Now be very, very careful here, guys. What would you do first? The 3's would cancel out. You must write this separately. So now that's log base 2 of 2 to the x. Yes, sir. No, you must write this first. And then once you write this, if you wanted to do x log base 2 of 2, you can. Or you could just say x. Okay, so are those inverses? Thank the Lord. Honestly, it's my belief that the fractions are the hardest. You would just say not an inverse. You would, if as soon as you hit one, that like let's say we had x plus 3 minus 6, you would say not an inverse. Stop. Yeah. We had that right up at the first one. Yes. You just have to pay very close attention. All right. So let's do some basic problems here.